So hello guys, today we are going to discuss about the problem of the prime subsequence. First of all, let us study the problem statement clearly. So we are given a positive number n and we need to identify and print output based on the below logic. So we need to find all the possible subsequences without any leading zeros. That means there should not be any zeros in front of the n. And basically a subsequence. What is a subsequence? A subsequence is either a contiguous or non-contiguous part of the given string or an array. So, but they should maintain the order from left to right. Okay. So, and then we need to assign the highest identified subsequence to the output. So, if there are no such subsequences, no such prime subsequences, we need to print -1. As we all know, 0 and 1 are not prime numbers. And consider the given input 50678. So 50678 is the given input. So you can clearly observe the formed subsequences here. So 5, 50, 506, 5067, 50678, also 507, 5078, 508, okay, 567, 56, 5678. So all these are contiguous and also non-contiguous subsequences. And so let us first consider only the contiguous subsequences part, as the test cases are mentioned only regarding the contiguous subsequences. So check out the below code. So let me clearly explain the code. So this is the main function and this is the function derived for prime to find whether the given given number is a prime or not. So I have considered this number input directly to a string input, and then I have generated all the possible subsequences by maintaining two loops, I and j. Now I will be traversed from every index so that at each index all the possible subsequences are generated towards its right. So I can be from 0 to n and j should be from the current index to the end of the list. So end of the string. So the current position is I and end of the string is n. So we generate all the substrings using this slicing method I colon j plus 1. So for example 506 is the given n. So I colon j plus 1 for the first string becomes, so I stays at 5 and j also stays at 5. I colon j plus 1 represents this 5. Now after the first iteration in the inner loop, the j increments, j goes here, and the second subsequence will be 50, and the third will be 506, and the fourth will be 06, and the fifth will be only 6. Okay. So these are the all possible subsequences, all possible contiguous subsequences that can be formed for the given n. So in this way we generate all the subsequences using these two loops and then check, and then we need to sort them in the descending order. Why descending order? Because we need to return the largest prime subsequence, so that when the number is largest, there might be a chance so that it becomes the largest prime subsequence. So we sort the array in the reverse order and then check from that point, and if any prime subsequence is found, we can return it and maintain a variable called flag, so that there is no need, if already a largest prime is found, there is no need for calculating the smallest prime subsequences. So break the loop, and if at last if there is no prime subsequence and the flag still remains 0, we need to handle this case. If there is no prime subsequence, then we need to print -1. So consider this prime number function also. So as we know, 0 and 1 are not prime numbers, so return false. 2 and 3 are prime, so return true. So factor of any 2 or 3 will be will be not considered as a prime number, so return false. And from 5, so from 5 each, from 6 each number will be represented in the forms of 6k, 6k plus 1, and so on, 6k plus 5. So in these possible formats, 6k, 6k plus 2, 6k plus 3, 6k plus 4 are divisible by either 2 or 3, but 6k plus 1 and 6k plus 5 are not divisible by both of them. So we take this condition if n mod I equal to 0 or n mod I plus 2 equal to 0, then there is no possibility that it is a prime number. So if any of these cases fails, then it is automatically a prime number. So let us consider the example input for prime number as 97, and the square root of 97 is approximately 9.8 or something. Yeah, 9.8 or something. So this is equals to approximately equals to 10, and 10 plus 1 is 11. So for every iteration, for the first iteration it would be 5. So 97 mod 5 is not equals to 0, and also 97 mod 7 is also not equals to 0. So it is false, it doesn't execute, and the increment of 6 takes place, but 5 plus 6 is 11, 11 is less than 11. So this case fails and comes to the last statement of the prime function, and it returns true. It takes approximately of square root of n complexity, as we are using add dot square root of n in for loop. So this is regarding the contiguous subsequences. I hope you understood this. So let us also check whether how to consider the non-contiguous subsequences also. So all the code remains the same, the prime function remains the same, and also the finding out the maximum prime number subsequence also remains the same. The whole change occurs when we need to find out the non-contiguous subsequences also. Uh, for example, 506. So the contiguous subsequences of 506 are 5, 0, 6, 50, 506, and 06. So these 6 are the contiguous subsequences of the 506. So if we consider the non-contiguous, 56 also will be added. 56 will also be added to the non this subsequences list, and we need to check whether these non-contiguous subsequences are also prime or not, to find whether the given the given number consists of contiguous and non-contiguous subsequences and the largest prime in it. So let us check out this function find subsequences and know how to generate the non-contiguous subsequences. So initially we have a empty list with an empty string. So for the first iteration, consider the same input 506. So the first for the first iteration, the single string 5 will be added to the original list, that is now the list becomes the empty string as well as the element 5. Now when the second iteration, the second character for each in S represents each character in the given string. So the second character 0 is now added to the original list, and it gets added to the each and every element present in the original list. So the list remains the same, and the additional elements that are added are these are the previous elements, and now 0 is added to the empty string, it becomes 0, and 0 is added to the 5, so 50 is the new So these four elements are present in the current list. And now when the third iteration, the third character comes, and this third character gets added to the all strings present in the previous state. So this 6 gets added to the all these 4 strings, and additional to these 4 strings, another 4 strings will be added into the list. Those are 6 plus empty string is 6, and 5 plus empty string is 56, and 0 plus empty string is 06, and 50 plus 6 is 506. So these 8 elements are present in the final list. So using this function find subsequences, we generate all the subsequences, and if we check this clearly, there is a leading 0 in this element 06. So here we are converting it into int so that there will be no damage done, and 06 will be converted to 6, and we check whether the number 6 is prime or not, and we update max and return the max. So hope you guys understood and got a clarity regarding these subsequences. Uh, Thank you.